Good afternoon, everybody. I wanted to take an opportunity to just close out our class and to do a very short lecture on the organization of practice. One of the reasons why I want to be sure to include this particular presentation today, which I will make very short, is that I want you to have this information as you move along in your studies and in your application of the field. Many of you have written to me with concerns about the total point value, including the extra credit points that I gave you for the first two exams. I want you to know that in the final analysis, once I have your total point value, including the 4.55 points, I will use that value against a 100-point system. So your concern about approximate 105-point system is certainly something I'm aware of, and I will not take that extra credit away from you. I want to remind you that your exam is scheduled for Tuesday, December 17th. We'll be meeting promptly at 9:45 in Washington Square Hall 109, which is the room where we met our Thursday classes. Please be sure to bring a T and E 200, and it should be completely filled out for 1 point. And the class is Kin 166, Section 1, and the course ID is 41512. Please be sure that everything is circled in, and you will get your 1 point towards your final exam score. I look forward to seeing you at the final exam. I wanted our last lecture to be about this principle related to the organization of practice. You'll remember that we were talking about Schmidt's model when we last had our class. And I want to bring you back to one of the first things we talked about in our labs related to what a paradigm is. A paradigm is a model. It's something that's used to test an idea. And so there is a paradigm for testing the variability of practice hypothesis. I want you to take a look at the first part of this paradigm. So let's say I have 3 different tasks, A, B, and C. Actually, they would be the same task with varying parameters. For example, a 50 mile per hour overhand pitch, a 55 mile per hour overhand pitch, and a 60 mile per hour overhand pitch. Notice the change in the parameters for those various pitches. Notice that during the acquisition phase of the experiment, the subjects are given 54 trials of practice. That would mean that they get 18 trials of each of these variations of practice. But that would only really mean what's called the variable practice group, or it only describes the variable practice group. In other words, notice that regardless of how I structure the variable practice order, the individual or participant actually has 18 trials of task A, 18 trials of task B, and 18 trials of task C. It's the order with which those trials are actually distributed that makes it a variable blocked group, a variable serial group, or a variable random group. You could see that in a blocked group, all trials of the task A or of the variation A are completed before beginning practice on variation B. As well, in the serial practice group, you could see that after a while, there would be a predictable order of practice. Whereas finally, in the random group, there is an unsystematic order of practice, and that would be referred to as random practice. This would be compared to a constant practice group. Notice that the constant practice group only practices a single variation of the pitch, maybe 50, maybe 60, maybe 70 miles per hour. And that's all they do for their entire 54 trials of practice. After acquisition, there's something called the retention interval. I want you to notice these two parallel lines here. When you see that in the paradigm, it means that there's an interval of time or a delay of time before the retention trials actually begin. And then finally, there's retention. And in the retention, I just want you to notice that I'm testing for task A. Retention, you would expect, or you might expect, would be better for the constant group, having had all of their practice around task A. But instead, what Schmidt actually hypothesizes is that even with reduced practice per variation of task, you can see how the variable practice group would be able to refer to the different variations of tasks or be able to complete the different variations of tasks better than the constant group. I also want to bring your attention back to what we refer to as levels of processing that was created, or the idea of levels of processing was proposed by two researchers. Their names are Craik and Lockhart. And these characteristics of levels of processing are important with regard to how we structure practice. So I want you to consider how meaningful, elaborate, familiar, compatible, how specific or distinctive ideas are. And I've given you a few ideas here about how you might create conditions of practice so that you are considerate of these characteristics proposed by Craik and Lockhart. And today I just want to quickly introduce to you the idea referred to as contextual interference that was proposed by William F. Battig. He was on my master's thesis committee in 1978, and actually the theory paper on contextual interference was published finally in 1979. Today, in 2019, later, you can see that, in fact, Battig's ideas are still very prevalent, and scholars have looked at this idea of contextual interference in many different ways. This is the apparatus, actually, that I used for my dissertation work. I want you to notice this button here. That's a reaction time key. So when a light shines up here, a subject would release the reaction time key, hit these telegraph keys in any order prescribed by a diagram on this box, and then finally finishing all tasks by pressing this telegraph key in the middle. On the back side of the carrel was the experimenter panel. I was able to change all the conditions of the task. I was able to see the reaction time and movement time for any particular trial. And depending upon how these bulbs lit up, I could measure error or performance on any particular trial. Shea and Morgan were the first to look at the contextual interference effect in motor skills, And the paradigm that they use, notice the acquisition and then retention paradigm, they looked at conditions of blocked versus random practice. Notice that instead of being concerned with the constant group, they wanted to understand how these conditions actually create different retrieval performances. And in the Shea and Morgan experiment, they actually measured retention after a blocked acquisition group and a random acquisition group at 10 minutes and 10 days. They also looked at a transfer task, same task, different parameters, on a more difficult and less difficult task. They were the ones who operationalized the contextual interference effect, and their results, in fact, provided very strong evidence for randomizing practice conditions to create contextual interference and thus facilitate or to maximize retention effects. So just to complete our class, I wanted you to see this hypothetical diagram that Battig proposed, essentially, where he was arguing that even though you see that during acquisition performance, the blocked group outperforms the random group. If you look at their acquisition performance, blocked will always be faster than random. However, notice the flip-flop in recognition. This is sort of the paradox of this learning effect. In other words, what we see during acquisition may not be what we see in retention or recognition. So I want you to consider when you're structuring practice what the contexts will be for your clients in physical therapy, in occupational therapy, in teaching, in coaching, and in strength and conditioning. I wish you really good luck studying, and I look forward to grading your exam and to completing our class by placing your good motor learning grades into my SJSU. Have a good one, everybody.